Well, I think we're around 6. And since James is in the Starbucks with a lot of background noise, I have the honor to speak his words, actually. That's what I will do. So, James, thank you for that. As you all know, James is one of the members of the board of directors of the Pari Center, and so am I. I'm the associate director. And well, let's start with the ground rules of a Zoom conference, as we always do. To start with, we will record the talk, Jan's talk. It's just for archival purposes, as you all know. You can look it back. We ask you all to keep your camera on, but mute yourselves so we can definitely hear Jan and hear what he's saying. Jan will further introduce how he is going to build up his talk, because there will be plenty of time for Q&A, I'm sure of that. So, let me start welcoming Jan. Dear Jan Walleczek, you're the director of the Phenoscience Laboratories in Berlin, and also the director of the Fetzer Franklin Fund and of the John E. Fetzer Memorial Trusts. And this is the organization that sponsored the Infinite Potential film. Well, and we all enjoyed that film so much. So we are very happy that that happened. Your scientific work is in the field of biology, chemistry, engineering, and physics. And in 2019, you co-edited the book Emergent Quantum Mechanics, David Bohm Centennial Perspectives. In addition to meta-science and advanced methodology, your professional interests include the philosophy and foundations of science. And I'm really looking forward to that, because you're challenging the role of the observer in science and the agent that the scientist is in science. So I'm really looking forward to what you're going to say about that. Today, you will be addressing non-locality, interconnectedness, and the quantum observer. Jan, I'm really looking forward, and well, the floor is yours.
Thank you for that introduction. Can I be the host for my screen share? Is that possible?
Yes, that is possible. And James is going to make that happen. It is happening. So you're totally in charge of whatever it is you want to do.
So you can see that?
Yes, we can. Yeah, it's perfect.
Okay.
Yeah.
Okay. So let me just start with this one. The reason I'm here speaking is, like you just said in the introduction, is that the Fetzer Memorial Trust funded the Infinite Potential movie that Paul Howard did, and he just did a beautiful job on this, I have to say. I will tell you the story behind it in a minute, but before we start on that, I want to tell you that it made full sense for us to sponsor this movie, because David Bohm was a science scholar in residence at the Fetzer Institute 30 years ago. And so here on the screen to the left, you see John Fetzer, the founder of the Fetzer Institute. At his age is 90 at that time. And David Bohm on the right-hand side, of course. And there was a nice dinner, and I just got this photo a few years back. I didn't know there existed a photo of that time. And just some background to John Fetzer. He himself was a radio pioneer, broadcaster. He's the inventor of the directional antenna. He owned 150 TV stations and then sold all of these and put his money into this organization, the Fetzer Institute, whose sole purpose it is the search for wholeness and to fathom the depths of consciousness in the universe. Very spiritual man, but with a solid science grounding. And so on that, you know, of course, David Bohm and he would meet, and they would have conversations on this. And so David Bohm was invited in and was sponsored to do some work, especially on dialogue also towards the later years at the Institute. What I'm going to do is to give you a brief background on what the Fetzer Franklin Fund is doing now, you know, studying the big questions of science. And then I'm going to, in the first part, go into non-locality and quantum interconnectedness. And in particular, from the perspective of mainstream science today. And because I've been asked after the movie so many times, how is David Bohm's theory viewed by mainstream science today? I know we're all, happy with Bohm's theory, but what is the controversy behind it? What does the mainstream say about the theory today? What is the controversy beyond just the politics, that we all know that happened? And that's part one. And after that first part, I want to stop maybe, depending on where we are in time, take a little break, maybe have some questions on that first part, and then move on to a second part on the general theme of wholeness in science, emergence, and the quantum, to continue really in the conversation we just had with Florent, on the question, is the universe a fundamental whole, and what's the role of the observer and the observed, and what is their relationship? The whole question of consciousness in the universe. And then to finish up briefly on the future of science and the question whether we can really move beyond reductionist science, materialist science, physicalist science, actually towards a new kind of relational science, one that integrates without reducing. So let me start just some background on the Fetzer-Franken Fund, because this is very unique. I've been director of the fund now for 10 years. I should say that I work now for almost 30 years with the Fetzer Institute. They sponsored a lot of my work, but the last 10 years, I switched sides and I'm now running the program and developing programs for the Institute. And what we're doing is the Fetzer Science Program explores whether the concept of wholeness can reach beyond philosophy, spirituality, and metaphysics, and in fact provide the foundations of a radically new kind of science, what we call a deeply relational science. What does that mean? Not a science that reduces consciousness and life to matter, but that allows for all those domains of existence to coexist without being reduced to each other. And that would, of course, would be an enormous breakthrough, and that might happen in the 21st century, or that might never happen. We don't know that, but that's the goal of this program. So for that, we have to ask, what is science in the first place? In particular, what is modern science as we know it for the last 400 years? And then we ask the question, could there be a postmodern science? Could there be a science beyond physicalism, beyond materialism, beyond reductionism? Not just as a philosophy again, not just as a spirituality, not just as a metaphysical system, but as a real science based on empirical data. So this is the big picture question that we're asking at the Fetzer-Franken Fund. What is the future of science? Reduction or holism, or both? Let's face it, reductionism has brought us, all the criticism on reductionism has brought us the quantum. Let's face it. Reductionist methods have brought us most of the successes in science that benefit humanity today. At the same time, the fragmented view, as David Bohm pointed out, that this provides is deeply constrictive and has created a lot of problems. And towards the end of my talk, I will return to that question. So the Fetzer-Franken Fund is really about creating breakthroughs, what we say, in relational science. If you go to the website, here's all the information. This is the landing page. We see that we sponsor work in 4 goal areas on wholeness and interconnectedness: in physics, in the foundations of science, in consciousness, and in biology. So these are the 3 big questions, right? What is matter? What is life? What is mind? These are the 3 big questions of science today. We are adding the question, what is science itself? What is this lens through which we look that is discovering the physics, the biology, or the psychology of life? And I just want to read these questions that are organizing this here. In our physics area on relational reality, we're asking the question, is the world intrinsically random, or is it fundamentally interconnected? Is the world local or non-local? And you can see that this goal area is fully inspired by David Bohm. Another goal area, we are looking for new visions of life. For example, could there be a universal definition of life beyond DNA? Can new informational techniques reveal novel forms of living organization? Can we recognize a form of life that we don't know yet? And finally, the area of consciousness on agency and free will. There we sponsor a lot of conferences and workshops and research projects as well, especially on the question, what is agency? And how do parts of the physical world attain it? A very controversial question, the way it's put. And what is consciousness and its place in the world overall? And finally, lot of work in recent years we put into what we call meta-science, the science of science. And we ask, what makes possible scientific truth and objectivity in the first place? And many people say that's not even possible. It's all subjective, as Hegel would say, but in an absolute sense, and we will return to that. And the question that's driving forward our work, especially in connection with, let me just look at this here. When we connect these two fields together, physics and foundations, we ask the question, are the foundations of science fixed, or are they actually open to future revision? Can there be a new kind of science based on interconnectedness, the kind of science we call relational? Now, of course, David Bohm was all about this. And so I think all these goal areas reflect the vision of David Bohm. And that goes back to his influence on the Institute 30 years ago. And yet, as you well know, he said, you know, this is a famous statement from Wholeness and Implicate Order. He said, science itself is demanding a new non-fragmentary worldview. He said that the evidence coming from science itself actually must transform science into a completely new form of science, one that is non-fragmentary, one that is relational and integrative. And this is reflected in our mission. This is the mission of the Fetzer Franklin Fund. It's to explore the frontiers of knowledge and to advance breakthroughs towards views of reality that are integrated and relational. That's what we do. That's our sole program. And so I think there's a lot of overlap with what we are doing and David Bohm's mission overall. What I want to start out with is to give you background on the work we've done on actually making David Bohm's vision more well-known in the mainstream of physics. So we started a conference series in 2013 on emergent quantum mechanics at the Academy of Sciences in Vienna, Austria, where also Basil Hiley was invited, and also Yves Coudet, who was mentioned earlier on the Walker. And then we had EMQ 15 in 2015, continuing in Vienna. And then the occasion of David Bohm's centennial celebration, we moved the symposium to London, to the University of London, to Senate House, which is right next to Birkbeck College, to celebrate David Bohm's life and work in science. And of course, as you know, he was born in 1917. On the 100-year occasion, we had that symposium, but also it turned out that to the day of his death, 25 years later, we had that symposium right next to his office at Birkbeck College. And as you can see from, this is the upper half of our poster, we had Basil Hiley as a lead-off keynote speaker. We had Sir Roger Penrose give a great talk, but also Yakir Aronoff, who you well know, was a long-term collaborator with David Bohm. And Tim Modlin was there, probably the #1 philosopher of physics today in the world. Ephraim Steinberg, who is featured in the movie, and Hugh Price of Cambridge, Max Tegmark, who you might know from MIT, and Matt Leifer, one of the leading theorists. This is where this event happened. We had a lot of great plenary speakers, about 40 talks, and I should say I co-organized this event with Paavo Pulkkanen, who you very well know. And he took part, he organized the philosophy side of things on the final day on the question, do free will and consciousness matter? And what is the future of scientific explanation? And we really felt this was necessary to do because, as the movie showed very nicely, starting in the 1950s, there was fierce opposition to this way of thinking, especially to the notion of an ontology in quantum mechanics. Remember what Oppenheimer said, if you cannot disprove Bohm, then we must agree to ignore him. Einstein said it's a physical fairy tale for children. You know, remember this despite the fact that Einstein called David Bohm his spiritual son before. Wolfgang Pauli said a check that cannot be cashed. And Niels Bohr, you know, really the founding father of quantum mechanics, he said very foolish what Bohm proposed here, to actually introduce an ontology. So a generation of physicists, as you know, were taught to ignore David Bohm's quantum theory. And so we felt it was time to take stock of where we stand and to make the case for David Bohm again in a very forceful way, open way. And in these meetings, actually, we invited, I should say, these speakers here in the true spirit of Bohmian dialogue. We had speakers there who disagreed completely with David Bohm. We had people there who disagree with non-locality, who provide alternative visions. So we had a real open dialogue between skeptics and proponents of Bohm's theory. And this is also reflected in the book that we published out of this, which I'm going to share with you a little bit later. But let's get to the heart. What was so controversial about this? What appears to be wrong with ontology in quantum mechanics? The fact that this ontology is non-local, that there is action at a distance at work, that there is faster than light activity at work, that there are so-called non-local causal influences. In short, the issue of non-locality. And I call Bohmian theory really Bohm-Hiley quantum theory, as the way it's been worked out now. And we should ask then, remind ourselves, what is this non-locality? And I know, especially in the talk with Chris Dudney, when he explained how he was doing the animations, he talked a little bit about that. But I want to just bring us up to speed. What is happening here in an experiment? And let's just look at this. Let's assume we do an experiment with two members of a quantum entangled pair where we measure a property of particle X, and we send another particle to Mars, which is entangled with X, Y, and then Alice performs a measurement on Earth. Let's say this could be a photon or an electron measurement, let's say on a photon, whether the plane of polarization is horizontal or vertical. And the moment she performs an experiment, the moment her measurement instantly fixes the value Bob will measure on Mars, her collaborator. Now, the key is instantly, as you know, because if there would be a signal transmission from Alice due to her measurement to Mars, it would take on average 14 minutes at the speed of light, given the average distance of Mars to Earth. But in fact, it happens instantly, like magic. And of course, this is the non-local influence, and this is called non-locality. And the key point here is the non-local influence between A and B is instantaneous in a common rest frame, in a non-relativistic interpretation, of course. Importantly, the non-local influence extends without limit, and it does not decrease with any distance between locations A and B. So as Chris Dudney said, it could be an Andromeda, the measurement, and one we do on Mars. So in that sense, it's really outside space and time, what is happening here. But that's not proven yet. I'm just telling, briefly I share with you the experiments on this, what we know for sure at this point. And most importantly, this non-local influence cannot be used to transmit any signals for communicating any messages between A and B, let's say between Alice on Earth and Bob on Mars. And that has created enormous confusions. And so I just want to point out to you a paper I've done in 2016 with Gerd Grössing in Foundational Physics to really, in a non-technical way, to tease apart the difference between this non-local information and signals and message communication and how they're all related. Because for decades, there has been enormous misunderstanding in the mainstream, and they used this whole point that signals cannot be used through this mechanism to really say that Bohmian theory is therefore wrong. But that rests on the confusion of simply conflating information transfers with signals and message communication. And in that paper, in a non-mathematical way, in a non-technical way, we've really teased apart those dimensions. And that paper had enormous success. We had thousands of downloads to clarify this issue. So just to give you, in a thought experiment, what is information transfer that cannot be used for signal communication? Because normally we think if I can share information with you, then I can communicate with you. But how is that possible? How is it possible that we can only share the same information, but never use it to communicate with each other? A very strange concept. And the way I show it to you is through this thought experiment. This is the radio and TV tower in Berlin. This is right outside my window, basically, the view, where I'm sitting right now. And imagine that Charlie wants to send, with Morse code feed, an SOS to Alice and Bob. So dots, 3 dots, 3 dashes, 3 dots. So you can control his transmission. He does 3 dots, 3 dashes, 3 dots. So he has full control over his transmission. And he can reach Alice and he can reach Bob. and he can send out his SOS, so he can communicate a message, SOS, I need help. This is called direct cause information transfer to Alice and Bob. But most importantly, for understanding this, there's also common cause information transfer between Alice and Bob. Even though Alice does not communicate with Bob, they both share the same message, SOS. That is the crux of the matter. Now, this is classical systems. This is obvious. This is just a standard radio signal. And, you know, like any radio person with a receiver can listen to the same radio station. We all hear the same message. But that doesn't mean we're communicating with each other. Only the source, Charlie, is communicating with the rest of the world. But Alice and Bob are not communicating with each other, but they share the same message. Now, if you had a quantum radio, in a quantum radio, your transmission cannot be controlled. That means Charlie, while he can now send dots and dashes, he has no control over the sequence of these dots and dashes. That means he can send out these informational bits, but he cannot communicate anything because he lost control over his Morse code feed. Nevertheless, there's long-range informational correlations between Alice and Bob for these informational sequences, which are random. So that's what they share. They share the informational content. They share the random sequence, but none of the involved players can use anything to any of this to communicate, you know, any message like "let's meet for coffee tomorrow." That's impossible, or "I need help." But what they all are sharing is informational correlations. And it turns out, when you do this on Earth and Mars using quantum technology, you can instantaneously do that. And Alice and Bob will share the same random informational bits instantaneously, which is not possible according to relativity theory, which is not possible according to classical physics. And that is the strangeness, really, of non-locality, of non-local information. So what people are saying is this is really should be interpreted non-locality as an informational theory. And indeed, Bohm and Hiley talked about active information in this context. But what you're having is you have long-range informational correlations across the universe instantaneously. So in this sense, the universe is informationally interconnected, but not in a way that we can use for anything useful as far as we know right now. And just to bring you up to speed where we stand experimentally today, you know, we are making these assumptions. We are saying this, you know, this happens between Earth and Mars or even Andromeda or throughout the universe. But the truth is this has been measured at 18 kilometers so far by Nicolas Gézin in Switzerland, by Hansen over 1 kilometer with electrons. And the biggest study so far proved non-local correlation at a distance of 1,200 kilometers. This was a study done in outer space using satellites, using entangled photons in satellite systems. This was done in China, a very costly experiment, and it proved that this works up to 1,200 kilometers. Nicolas Gézin in this study proved that for sure, this connection, this informational connection that we describe with non-locality must be faster than 10,000 times the speed of light, at least. So we have at least 10,000 times the speed of light speeds. And of course, theory says it should be absolutely instantaneous. There should be, it's not even a million times speed of light or a billion, it's simply instantaneous. Now the key question is, you know, what's all the fuss about? The key question is, are these non-local connections merely a mathematical construct, which is the orthodox view? Or are they evidence for real non-local ontic causal elements in a radically new conception of reality, quantum reality? You might think, well, we have these experiments, right? So there is no doubt about this phenomenon. But the textbooks say, and Niels Bohr's interpretation says, we cannot say anything about an underlying reality. It's a mathematical model that we use in which these things show up. But so we can make these observations, but these observations, as it turns out, they're only local, right? Alice only observes her random sequence on Earth. She cannot at the same time observe the random sequence on Mars. And Bob only has local observations going on. He only knows what's going on his side of the thing. Since any verification and communication to Alice would take him at least half an hour back and forth, way slower than the speed of these correlations. So that's why the mainstream of physics is really not very fond of this idea of non-locality. Because basically it would say that there would be a quantum reality at work that is non-local from the ground up. So the question is, and that's what David Bohm said, of course, and that's what we in our symposia and conferences and the work we sponsor are looking at. The question is, are we living in a non-local universe which is fundamentally interconnected? Or, as the textbooks say, as the mainstream says, is the universe entirely local? And the non-locality an operational illusion? And that, in a nutshell, is the controversy that we're seeing today. And so where does this debate come from? Just briefly, there's only three papers you need to read, and you have the whole layout of non-locality. Einstein, Podolsky, Rosen, but certainly John Bell of Bell's theorem. And John Bell was a big defender of David Bohm. This was the seminal paper in 1964, where in an interview later explained, non-locality means that what you do here has immediate consequences in remote places. And in that interview, he was sitting on his desk in Geneva, and he said, what you do here at the desk, and he pointed with his other hand to the mountain peak of Mont Blanc, the highest mountain in Europe, and said has immediate consequences over there at this peak. And of course, he was referring to non-locality. And, but Einstein, Podolsky, and Rosen, and remember, this Nathan Rosen was the mentor of Yakir Aronov. You saw the director's cut of the movie. And this is David Rosen. And he was part of that original major paper. And and Einstein and Podolsky and Rosen included, quantum theory must be incomplete because otherwise the world would have to be non-local. And since Einstein rejected what we call spooky action at a distance, or as Bell said, that actions have immediate consequences in remote places. And therefore, in this case, Bohr and Einstein actually agreed. Remember, these two giants of quantum physics, they didn't agree about much at all. But on this case, they were unified in their opposition to the idea that real non-local influences might exist in nature. They agreed that real non-locality cannot exist. And in fact, Niels Bohr said that suggestion is very foolish. And Einstein said that's a fairy tale for children. So you can see this view is the textbook view until even in the year 2020. That's why we felt it was really important to bring this out. And of course, as you know, with his hidden variables paper in 1952, along comes David Bohm. And he published an alternative approach towards accounting for these correlations based on this controversial idea of real non-locality, the non-local interconnectedness of reality. In 2020, we call these non-local quantum theories ontological or psi-ontic quantum theories. So is the universe local or non-local? According to Bohm, the universe is non-local. According to Bohm's theory, the world is not random, not in an intrinsic way, but it is fundamentally interconnected. Remember, the importance here, it's not intrinsically random. The textbook view of Bohr would say that there is a fundamental indeterminism at work in the universe, blind chance from the ground up. Bohm's theory is, of course, deterministic, but not in a way where the determinism fixes everything ahead of time. And I will get to that in the second part of my talk. Determinism in a way that acts without predetermination, and that's possible. That's the concept we need to make Bohm's theory work, and that has been in the works in the last years. So what allows, in fact, yes, the universe is interconnected. It is nevertheless unpredictable, but it's not intrinsically random as the textbooks would have us. So what are these hidden variables? To put it very simply, in this theory. And again, John Bell, who really was a fan of David Bohm's. In fact, his whole paper was inspired by actually Bohm's theory, for which he actually said, I saw the impossible done in what David Bohm did. And he said in 1976, the usual nomenclature, hidden variables, is most unfortunate. perhaps uncontrolled variable would have been better. For these variables, by hypothesis, for the time being, cannot be manipulated at will by us. So what this means is these are properties of nature that are in principle inaccessible to measurement, in that sense hidden. They are unobservable, yet real. And as you imagine, you know, science does not deal with things that are unobservable and real. So in short, these hidden variables are uncontrollable variables by an experimental agent. And in this sense, they represent a new hidden regime of reality. And I think I mentioned that in the movie as one of the major insights from working with Bohm's theory. If Bohm's theory is correct and is proven right, then we have proven the existence of that hidden regime of reality. And that would really require a completely different kind of science, because what is a science where things are real that can never be observed and controlled? That is really not the kind of modern science, you know, that we've worked with during the last 400 years. Just for those of you who are interested, I've unpacked that in non-technical language, in non-mathematical language in this paper in Entropy last year. And I defined this principle behind this as the agent inaccessibility principle. And in fact, it shows how the objective unpredictability and the uncomputability of quantum events is retained even in these deterministic theories by David Bohm. And in that sense, it is this principle that makes Bohmian theory fully compatible with relativity theory. When we started out doing this work 10 years ago, this was a highly controversial thing. But I think now, since the EMQM 17 symposium and the book that came from it, I think people understand what's going on here. And they start accepting those dimensions of Bohmian theory. If you don't have this, then you have a hard time accepting Bohmian theory. John Bell, also the same John Bell, you know, just briefly on politics and science, on ignoring Bohm, just to say that. In the 1980s, John Bell defended Bohmian theory against the orthodoxy. He said in an interview, "This theory is equivalent experimentally to ordinary quantum mechanics. It is rational, it is clear, and it is exact, and it agrees with experiment. And I think it is a scandal that students are not told about it." Why are they not told about it? I have to guess here, there are mainly historical reasons. In any case, he said, "This scheme is a living counterexample to most of the things that we tell the public on the great lessons of 20th century science, namely that science is objective and neutral, and that scientists go wherever the truth leads them." And he says this was an example where this went terribly wrong, where because of ideological biases, this did not come to the fore. And remember, this is now almost in the 90s. This is 1989. We are still in that situation now. So we have, that's why it was so important to us to make the symposium. More than 350 people showed up. A book came from this, and it's a big volume with a 500-page book, which is the most probably complete and updated version on the Bohmian perspective. The book is called Emergent Quantum Mechanics. It has 32 chapters. By now it has more than 50,000 downloads. It's probably the most successful book of the publisher. So there's enormous interest in this. And this book covers interpretations, non-locality, contextuality, quantum ontology, information in quantum theory, quantum observation, the physics of the agent, nonlinear methodology, self-organization, quantum emergence, hidden variable theories in relativity, and emergent space-time, and was really happy to co-edit this with Basil Hiley and Pavel Pulkkinen, and also with Gerd Grössing, who unfortunately passed away last year. But I'm so pleased that this happened and that we got this done. I should also point out that the contribution by Basil with Peter van Rieth at UCL caught the attention of the publisher, and they actually made this article the cover image of one of the issues of the May 2018 issue of the journal Entropy on quantum trajectories, real or surreal. So where do we stand today? And also, I should say that, you know, what's the mainstream science's position on Bohmian theory in 2019 or 2020? We had Nicolas Jezin there, who is one of the leading quantum theorists in Switzerland. from the mainstream. And I just want to show you in relation to Bohmian mechanics, which is another variant of the Bohm-Hailey theory, but he concluded Bohmian mechanics is deeply consistent. It's attractive to philosophers because it provides a clear ontology. However, it is not as attractive to researchers in physics. And he concludes, this is unfortunate because it could inspire brave new ideas to challenge quantum physics. What you're saying is here we are 70 years later almost, after the original publication of the hidden variables theory in 1952. And even 70 years later, mainstream people are only starting to take this seriously, to dare to take up these concepts and to work with them. And certainly Nicolas Gézin, very open-minded mainstream researcher, really recommends that people take another look at this. But this is how this went. So this is probably all due to ideology and politics, but even leading mainstream researchers can't find anything wrong with this. And so my hope is, maybe we're seeing a transformation of scientific worldviews from randomness to interconnectedness. And we do hope that we play a small part in this, in setting up these symposia. We're also sponsoring the work at UCL on the quantum potential with Basil Hiley and Robert Flack for several years now. And we hope to get a signature for these trajectories in the system that Basil talked about, I think, here in the summer school series as well. But maybe there's a chance to go beyond blind chance and randomness models into interconnected models, as is represented by David Bohm. Of course, David Bohm understood all of this long time ago. And David Bohm said, of course, relativity and quantum theory agree in that they both imply the need to look on the world as an undivided whole, in which all parts of the universe, including the observer and his instruments, merge and unite in one totality. In this totality, the atomistic form of insight is a simplification and an abstraction, valid only in some limited context. And so the second half of the quote, the observer, will then bring me to the second half of the talk. So we have a choice. What we can make here is either take a break or have some questions, on the first part, on non-locality, interconnectedness, the politics, the relation of Bohmian theory to the mainstream of science today. Or we can continue. So whatever you suggest, we can do.
Are there any questions right now, or are we just kind of hoping Jan will continue as soon as possible? Anybody?
I got a question.
Yes, Peter.
I keep coming back. It's a question that I directed to Basil Hiley recently, and I keep coming back to it. I had a very simplistic view of the measurements of these two particles which are entangled, and I asked him, well, how on earth can you contain these two particles at 1200 kilometers or on other sides of the universe and measure them? And he confirmed that this is a dynamic situation, that you're measuring a stream of these particles. And I accepted that, and that seems logical. But I still keep coming back to the idea, well, if you're measuring a stream of particles from one place, A, Alice, to the other place, B, Bob, then there must be some time difference for the photons or subatomic particles, whatever they are, to get from A to B. So how can you measure the instantaneousness of the whole thing?
I think there's an easy answer in a sense. There needs to be a common source from which these particles are sent. One member of the pair to Alice, to Earth, and one member of the pair to Bob on Mars. And,
right.
And during their travel, you're absolutely right, Peter, during their travel, they need to be absolutely protected from interacting with anything else in the universe. They need to be kept from decohering, as the physicists say. And unless you protect them in that way, you cannot do the measurement. So with the 1,200 kilometers measurement, the reason they did it in space was because space is empty and there's a higher chance of not having any interactions with any of the particles as they travel 1,200 kilometers. And that's the trick in this, right? So you're absolutely right. If there's other interactions, they would destroy the entanglement and the non-locality would disappear instantly. So absolutely, the two members, they originate from a common place, but they fly off in opposite directions, let's say, to Alice and Bob. And as they travel there before the measurement, they need to be protected from the rest of the universe. Otherwise, this wouldn't work.
I see. Okay, thank you. Yeah.
Anybody else?
Yeah, there's somebody else. Wait a minute.
Sharon?
Gary has raised his hand, and Katrina, and I see, well, let's start with Gary and then go to Katrina and then Sharon.
So I have two comments and one question. The first is how this, I think this all relates to the deep nature of time. Okay, and actually that can be traced back to a debate between Albert Einstein and Henri Bergson that occurred on April 6, 1922 in Paris, but that's a whole other story. The second is that there is a science of relationality, and that science is called semiotics. I think we will gradually learn how important that science actually is. And I'm not talking about semiology, which is limited to language. I'm talking about science as the semiotics as the way that we interpret our experience. And the last question, the question I have is, how does this relate to the mystery of quantum gravity?
Well, the big open question is, and we had talks at our symposia exactly on that question. The issue of non-locality is completely unaccounted for in any theory of gravity. Gravity is, of course, since Einstein, a general relativity, a space-time property. It's not a separate force. It, in fact, is space-time itself. And since non-locality exists beyond or outside space-time, the two can't talk to each other. And that really is why we are stuck for decades now in trying to unify, the three forces that we can unify, the strong, the weak force, and electromagnetic forces with gravity, because there simply is no language even to connect these two worlds. And, many people see this as, this is the last remaining frontier of physics. I, of course, would say the last remaining frontier is more in the line with what you're saying, semiotics, understanding meaning and consciousness in this big picture. But certainly the unification of gravity with the other forces and the quantum is the big open question that's driving everything right now. And that's the reason also, I think, because we have this sustained inability to make progress here, that people look at David Bohm again. And I think I mentioned that in the movie as well, that David Bohm, he did provide an ontology with the quantum potential at least. And that quantum potential is sort of existing in our domain of space and time, and at the same time it's outside space and time because it has this non-locality, or if you want to view it another way, it has this time symmetry, right? Because you can also interpret non-locality as a local time symmetric phenomenon from actions of the future into the past. So
it's the spanning of space in a moment of time, right? I mean, in a sense, right? And
that's the contradiction, right? Because we always speaking about the space-time continuum where you can't separate the two.
That's the block universe that doesn't exist.
Exactly. So thank you. Good question.
Let's go to Katrina Bos. Katrina, you raised your hand.
Yeah. Hi. So what keeps striking me is our language, that we keep talking about interconnectedness, which sort of assumes that it isn't an undivided whole, right? We talk about the time from here to there and how it gets passed, and isn't that confusing? But when we actually imagine it as an undivided whole, more like what David was saying yesterday with the submerged, connected, collective unconscious, then suddenly wondering how it passed through time from this space to the other doesn't make any sense, because we are assuming a fragmented world. And
again, you're very right about that. And if we talk about the undivided wholeness, the interconnectedness, let's say the interconnectedness David yesterday was talking about I think Jung called it the pleroma, David Bohm called it in implicate order. That's a metaphysical statement, right? Which I very empathize and sympathize. But as a scientific statement, we have no evidence for that, except in this particular experiment that I just laid out to you on non-locality with these entangled pairs of photons or electrons or what have you. That's why I focused on that one, because I'm interested in where is the intersection between the philosophy of David Bohm, the metaphysics of David Bohm, or even the spirituality of David Bohm with contemporary physics. And that's why this concept of non-locality is so important, because on the one hand, it speaks to our intuition about the deep interconnectedness of it all, of the non-fragmentary nature of our existence. And at the same time, it's a scientific fact that we can observe under controlled conditions in the laboratory. And that makes it so exciting. That's why I also gave it a new title, right? I talked about the future of science in this context of non-locality, because if there's any chance for science to transform into a sort of relational science, accounting for the whole of it, matter, life, consciousness, all of it, we need to start with what the scientific facts of today are. And I think David Bohm was a genius in that, right? And I think David yesterday pointed that out as well. He said, David started out with the science, and then he expanded it into all these territories, wherever it took him. And he had no fear in doing so. He could do this because he had high credibility. I mean, after all, he worked with Oppenheimer, he worked with Einstein, he worked with all the greats. Today, you go to any esoteric bookshop and you have hundreds and thousands of books on this. But we don't have a breakthrough yet in new thinking in the laboratory on the evidence. So we are all very good at the philosophy and the metaphysics, but what we are trying to do is to do the new science on it, right? To have actually breakthroughs in science on that. And it's always grounded exactly in what you're saying, in this conviction that underneath all of it, it's all interconnected in exactly the way, Katrina, you're talking about. But again, that's the difference between metaphysics and physics. We want to take metaphysics into the physical realm. And that's where, and only if you have these concepts are you actually motivated to do so. And I think this is the big contribution of these concepts. If there would be no vision like that, there would be people would not be inspired to even go there in the lab. And I think because of this metaphysics of David Bohm, people are inspired to search for it in the lab.
Thank you, Jan. We have Sharon and Joy, and then I propose we continue with your talk, or if you want to, Jan, we can have a 2-minute break or something. But first, let's go to Sharon and then Joy. Sharon.
Thank you. Where my mind has been going is exactly where you're talking now, Jan, about the spirit, what I would call the spiritual dimension in David Bohm's thinking, and what comes to mind about all of this. So when you say that there's this, thing out there that transmits, transmit, I know is not the right word, but that, can be known or is an intelligence of some sort that is instantaneous, right? That, to me, what that's posits is the possibility that, excuse me, that there is a real truth out there, a real truth, right? A truth that we cannot interfere with. When you said uncontrollable by an experimental agent, that was just so exciting. The concept that no matter what we think about it, no matter what our bias is, no matter what we try and do, it is true. It is itself, right? Which is so incredibly exciting. Of course, you're trying to prove it, right, scientifically, and spiritual seekers are trying to understand that all the time. That's sort of, part of the major quest. What is it that is out there that through other means than science, we can maybe know, we can maybe perceive? So I wonder if you've been thinking along those lines as well and trying to look at both the discipline of spirituality along with the discipline of science.
Very good. what struck me in doing this exploration with David Bohm, and especially these later years on understanding this uncontrollability aspect, right, of the agent, this inaccessibility, that this postulates there exists a hidden regime of reality that will forever stay untouched. That means the arrogance of science, right, that we will eventually know everything, is shown to have a fundamental limit here. And the modern scientific framework operates under the assumption that one day we'll know it all. What this tells us, if this quantum theory is correct, it tells us, no, there will always be a domain of reality that will forever stay beyond control and knowledge by scientific agents. And the mystics have always told us that. You know, this, I think in the movie I'm speaking something like, we must be humble in front of reality, right? A deeply spiritual person appreciates being part of reality, but there is no need to control it. Mm-hmm. Actually, we're in the mode of accepting rather than in the mode of control. And I think and scientists usually are in the mode of controlling everything, right? It's all about prediction and control. And if Bohm is right here, and the existence of the quantum potential can be proven, then the domain of that hidden domain of existence is proven. And it tells us even science must accept that limit. And it's there where science and spirituality converge.
Mm-hmm. Thank you.
Joy.
Hello. Gary asked one of my questions already. As I'm not a scientist, I'm a psychologist, but I have thought for a while that that gravity is like the theory of gravity is, it's like if you go against it, then you're betraying your heroes. And people get very loyal to their heroes. But I don't know, I think maybe it's needs to be looked at differently. But besides that, it's what I see here is that there's the paradox, which has been outlined pretty clearly, which is non-locality versus locality. And it seems to me that what the scientific community is doing in physics is some of you are holding those different viewpoints. And so that's how you work with paradox. So keep doing it, and maybe something new will come up that you can't even imagine. And I think it's very exciting. What I love about psychology is I'll never know it all and never get to the bottom of it. And so to me, that's what I see happening here. And those who think they can know it all, either they'll have a wake-up call or be very frustrated. I don't know. But anyway, I just, I think it's a paradox, like any other paradox. It's just really big. And I think it could take us in exciting directions. So it's very interesting. Thank you.
I will speak to a little bit about that in my second half. It's a perfect lead in into the second half, where I'm going to talk about the paradox that arises due to self-referentiality, that two things need each other, but they're also opposite, but they're also unified at the same time, right? The paradox that we encounter in the Tao, for example. So I'm going to talk about that in the context of Hegel in the second part.
Okay, yeah, I think we're working really hard to expand our own awareness, and we're not there yet, and that's why we can't bring those opposites together yet, but hopefully we will. So thank you, I look forward to it.
Thank you, Joy.
Great introduction, Joy. Thank you to the second half, as I hear you, Jan. I suggest that we just go to the second half of your talk and then take it from there for the next round of questions. Is that okay?
Did you want to take a 2-minute break, or didn't you want to?
Yeah, maybe that's a good idea, that we have a break. People can get something to drink or, well, whatever they need to do. So let's have a 2-minute break.
Okay.
See you all. Slowly everybody's coming back. So I think, Jan, when you're ready,
Okay.
2, 3, yeah.
Let me just. So the second part is really on wholeness in science, emergence, quantum, but it's really a response to David Bohm's idea about implicate order, explicate order, enfolding, unfolding, and what the closest would be that we have in science today, where one could work with that. And that's the concept of emergence, and I will get into that. So let me start with this. And the concept of interconnectedness in its relation to the relational concept of enfolding and unfolding in Bohm's thinking. And of course, here's this famous statement by David Bohm where he said the essential feature in quantum interconnectedness is that the whole universe is enfolded in everything, that each thing is enfolded in the whole. And this is really, David's talk yesterday got us deep into that. Of course, this is in the tradition also of, I just mentioned these names, of Aristotle, Hegel, Schelling, Husserl, and Whitehead, who all have pursued one form or another of going from unmanifest to the manifest, going from potentiality to actuality. Very different philosophical systems, but starting with Aristotle, that was the break from Plato at the, in classical Greek times. Introducing this idea that things exist potentially, they're not manifested, and then by acquiring form, they become actual, they manifest. And this, you could think of this as going from the implicate to the explicate. That has, of course, a long philosophical tradition, this way of thinking. Because it is, but I want to emphasize the thinking of Hegel here. And as it turns out, this week is the celebration of the 250th anniversary of Hegel here at the University of Berlin. That's where this German philosopher did his work. And as we know, David Bohm was citing Hegel, was inspired by some of Hegel's ideas. He tried to move beyond Hegel's ideas. But this week, as I said, is a big celebration in Germany on this way of thinking. That's why I want to connect David Bohm's thinking to Hegel to deepen some of these issues. I found this very interesting interview with the American Institute of Physics, where Maurice Wilkins, the Nobel laureate, the co-discoverer of DNA, he was the X-ray. He provided the X-ray structure for DNA. Interviewed David Bohm in March 1987, and here Bohm in that interview says, "I was explaining with Hegel the idea is first implicit only in itself, and then it unfolds. It spreads out in the imagination or in some other form like writing or painting. It becomes explicit, unfolded. You could say the painter's idea is implicit, but made explicit, unfolded on the painting." And here he went on. David Bohm said, Hegel says, it's all there already, but it unfolds. And then he says, he talks about the translation of the original German into English. That has been translated as development. The better translation David Bohm proposed, probably, the meaning would have been unfold. I'm sure it was a good translation of a German word, but I think the way Hegel uses the word development is roughly the way you would use the word unfolding. And it turns out that actually in the translations, some of the translations actually have unfolding. So I don't know if David Bohm is aware of that. So what I'm suggesting here is, and because I looked at Hegel's work for several years as well in relation to David Bohm, and what we can see here is I want to draw some parallels, and we can discuss, where the parallels are and where they aren't. But in 21st century science, similar talk of enfolding, unfolding happens in the domain of emergence theory. So unfolding as emerging. So This is very similar to the emergent forms in emergence theory. And what is described in emergence theory is the dynamical process of emergence of the self-generation of order from non-order, which is, to me, equally radical as non-locality, by the way, right? This is next to non-locality. This, to me, is the most stunning insight of the 20th century, is that order can arise from randomness. And I will briefly talk about that, give you some background, because this was my specialty area for 10 or 15 years while I was working at Stanford. So what is emergence? Emergence goes under many different names that you might have heard: complexity theory, chaos theory, self-organization theory, nonlinear dynamics, fractal set theory, cellular automata, synergetics, or open systems theory. And what all of these share is that they all deal with emergence events. They have sensitive dependence on these initial conditions. And David Bohm also talked about that. And actually, this is also part of the undivided, the book with Basil Hiley. They all describe the rise of global order from local randomness. And most importantly, they describe a state transition from indefinite to definite states. So from potentiality to actuality. So what you seem to have here is, in fact, a science of emergence that reflects many of those metaphysical or philosophical interests that come from Aristotle through Hegel, Schelling, Husserl, Whitehead, and David Bohm. What they all share is that they're describing, let me just show you here, the rise of an emergent structure, and I'm going to give you some examples of that very soon, from random interactions. So that structure is not here, but it arises. And just some technical terms so that you know, for you physicists, what we're dealing with here. This is non-equilibrium thermodynamics. This is the conversation that we had at the start of the talk on these walkers, these systems by Yves Coudet in Paris. They're based on that. These are all self-referential recursive processes. They're computationally non-reproducible. That means with all the information available, you cannot compute the outcome from these experiments in detail. So you have, because of the self-referentiality in the systems, you would require an infinite amount of computational resources to predict the outcome of individual events here, which of course you can't. So it's unanalyzable in that sense of David Bohm. So these are all deterministic processes, but it's a determinism without predetermination. That is key. There's a lot of criticism always, right? That David Bohm's theory is a deterministic theory. That means everything is set up at the start of the universe. And as the universe unfolds, everything that is already, all that was, only the things that can only be actualized or become explicate are only those things that have been there from the start in the hidden domain, in the implicit domain, in the invisible domain. But here you really have another way. You actually says that, yes, everything is determined. We live in a deterministic universe in accordance with Bohm's theory, which is a fully deterministic theory. But in the process of the universe, as this unfolds, this determinism is not paired with predictability or computability or decidability. But all these things remain undecidable. They cannot be predicted and not predetermined. So we have a certain degree of freedom here, even the freedom in a deterministic world. So I'm just going to give you some examples. What are these emergent events or structures? And we talk about self-organizing relational dynamics. And I'm going to just use the example of the spiral. To the left, you have the spiraling arms of a galaxy, hundreds of light years across. Then next to the right, you have a hurricane with hundreds of miles of across with these spiraling arms. And then you have these microscopic systems, which are millimeters and submillimeters. This is a Belousov-Zhabotinsky chemical reaction, which generates spiraling waves in an open flow system under nonlinear and open conditions. Or this is a spiraling wave on the platinum electrode surface. So you have these global structures, which are forms, in this case, spiraling forms, and these are emergent events. And they occur to us phenomenologically at the macroscopic level of what we can see and perceive and detect. But where do they come from? they come from the microscopic realm, right? At the microscopic local realm, what you have is there's the random interaction going on of elemental units, local microscopic interactions, which give rise, like magic, to these forms, these spiral forms. And what I want to show is, and the question is, and this is the big unknown, how do these local microscopic interactions, how are they connected to these emergent global structures that we perceive? And that, to explain that, that is, emergence theory tries to explain that. And this is also, of course, the question of reductionism, because this is the level of reductionistic events, local microscopic interactions, the atoms, if you will, the molecules, if you will. But how do they organize in these holistic structures? How does this holism happen in the universe? In the end, the whole universe as a whole. And that is accounted for by emergence theory. And as you can, when you look at this, we could say, we have an example of order from non-order. And this example here is this Belousov-Zhabotinsky spiraling reaction in the test tube. In a Petri dish, in fact, this is happening. So this is the emergent form of spiraling. And remember, you know, when we heard Leroy Little Bear talking about, you know, Blackfoot language, this is not a spiral. Yes, it looks like a spiral as a static object, but in fact, it's spiraling. It regenerates itself. It constantly appears and disappears, and it gives the illusion of stability, but it's really order from self-organizing dynamical flows in this open flow system. And you might say then, at the lower level, we have the unmanifest potentiality. There is a spiral somewhere here in these interactions, but of course it isn't. And the moment you cross into the global realm, the spiral becomes manifest in actuality. And so this is a very similar model to implicate explicate. So the spiral would exist implicitly in the implicate order, then it would manifest in the explicate. And emergence theory has very similar concepts, very similar sort of metaphysical assumptions underneath the theories. The difference is that we can do experiments with that, and then we can do models with that based on nonlinear differential equations. Normally, we talk about top-down causation, right? That the higher level, the higher order properties of the world reach down and organize the lower properties of the world, which would be a real holism, top-down causality. This would be the Aristotelian form, for example. Aristotle would have this as formal causality, as one of his 4 different types of causes. Reductionism, of course, says all we have is bottom-up causality. So everything is random at the bottom, and these random elements interact, and they give rise to all the structures we observe in the universe, including the whole universe itself. This is bottom-up causality. Now, in emergence theory, or in this relational theory, you have top-down and bottom-up, top-down and bottom-up causality at the same time in one great synthesis. So you cannot dissect top-down causality from bottom-up causality. That is the genius of emergence theory, of a relational theory of the world, that you have to have both these flows. You have the top-down flow of the whole to the part, and you have the part must be able to connect to the whole. And in this continuing interaction, so this is a dynamical state. This is why you have these errors interacting, all these, you get these structures emerging. So it's order from self-organizing dynamical flows. Not only can you have that, you can have it at many different levels simultaneously. So you can have nested hierarchies of these states connecting different organizational levels. So one element, one local microscopic element of one level in the hierarchy can be itself an emergent macroscopic structure. And again. So you have a scale-free relational continuum where you have hierarchies within hierarchies within hierarchies. And this is, of course, known as the fractal universe model. That's where it originated as a first concept. And of course, all living organisms are organized this way, right? Cells to tissues to organs to the whole body. They're all interacting. They have all these levels that are cross-cutting and you holes within holes within holes. And so what I was very interested in over these years is to connect Bohm's thinking of implicate-explicate order to the science of emergence that I've been doing for 15 to 20 years of my life. And so I see a lot of parallels in that way of thinking. So you could imagine this is sort of a holographic model as well, right? It's very similar to the holographic model. It's also very similar to the concept of holo movement in David Bohm's work. We call it a relational continuum of nested organizations. 20 years ago, I did a book on this, and I'm just going to show you these upper, which was all on these self-referential processes, self-organizing processes on the top. And it doesn't matter whether this is non-living matter, or whether this is living matter, or whether this is neural states. This crosses all organizations of all types of realities, the non-living reality and the living. This is the spiraling wave in the chemical reaction. This is the spiraling waves that occur when an electron hits a charged platinum surface. So the upper two images are spiraling forms in non-living systems. This is how your retina looks when a photon hits your retina, when it excites the state of seeing in your brain. It excites a spiraling wave on your retinal surface. This, of course, these spirals are from slime mold as they organize these amoeba-like structures when they organize and reproduce. So there's spiral forms everywhere, whether in non-living systems, living systems, but also in the brain, also in on and on and on. And in this book, I describe some of these. And they're all a result of the self-referentiality of systems, where levels interact within themselves. They feed back on themselves. And this is the connection to Hegel's organic philosophy of nature. And as you well know, as I said before, David Bohm not only dealt with the dialectical materialism of Hegel, but he was interested also in his philosophy of nature itself, which is an organic philosophy of nature for the whole of nature, including matter. But what underlies all of Hegel's thinking is, in essence, the idea of self-reference. So, for example, Hegel says, regarding the identity or self of a living organism, he says, the self is an infinite self-relating form. And already 200 years ago, more than 200 years ago, Hegel says, a living organism is an infinite self-stimulating and self-sustaining process. And here we are 200 years later and having the same language in science and emergent science, looking at life as a self-sustaining and self-stimulating process. And to Hegel, what made the whole of the universe organic was this idea that in life, the resolution of the opposition between concept and reality, between mind and matter, between consciousness and nature, are resolved. And I'm going to go to this next. So this is what Hegel said regarding the illusion of object in nature and science. He said, my object is no longer an other, but it is myself. In a nutshell, he's saying the observer is the observed. And you can see the resonance here between Hegel's thinking and David Bohm's thinking that is revealed here as well. Now, in Hegel, the original opposition of consciousness and matter, mind and matter, is resolved in the emergence of life. So he says, actually, the developmental trajectories of consciousness and nature reach their goal in the emergence of living organisms, which make possible the conscious self. So, as I said before, for Hegel, life resolves the opposition between mind and matter, between concept and reality. So he's saying it's only in appearance that mind and matter are opposites. He's saying any living organism, and human beings in particular, are exemplars of the unification of mind and matter. And therefore, everything in the universe that is observed is equal to the observer and vice versa. Very radical notion of wholeness. The philosophy is called absolute idealism, which is really the high point of German idealism, the end point almost, but it grounds itself fundamentally in the idea of self-referentiality, that the self can only refer to itself. In the end, Hegel would say, like Goethe also, who lived at the same time. Goethe would say, you know, that universe and self are one, that the separation, the fragmentation we experience is an illusion. And of course, David Bohm loved that, and he took that into the realm of science. He took that into his dialogues. He took that into his work with Krishnamurti, and he had no fear in bringing up these radical ideas in the scientific concept. Very successful. Of course, famously said, both observer and observed are merging and interpenetrating aspects of one whole reality, which is indivisible and unanalyzable. And remember, this unanalyzable really points to this idea that we're dealing here with something, when something is whole and one, the moment you apply reductionistic methods, you lose it. And this is what I really mean by relational interconnectedness in this talk. So we really, what we have here, I just made the case to you of another kind of fundamental wholeness other than quantum wholeness. So we really have right now in science, we can work with two different types of wholeness. The emergent wholeness that I was talking about in the second half of my talk, and the quantum wholeness that I was talking about in the first part of my talk. The emergent wholeness I just talked about is based on the notion of self-referentiality. When coupled with nonlinear and open systems, give rise to all these emergent structures we experience around ourselves. Now, the important difference to quantum wholeness is that this interconnectedness that allows for emergent wholeness, this interconnectedness of everything is within space and time. It does not violate the space-time continuum. It does not violate relativity. Here, the universe is a fundamental whole in a constant state of flux. When I say fundamental whole, then that means the whole is not just simply derived from all the parts we can know about the world, but actually the whole also acts on the parts, and in return, the parts act on the whole. In that sense, the whole is fundamental and not just a figment of the imagination or a supervenient thing or an epiphenomenon, but it is fundamental in that sense I described before of top-down causality in conjunction with bottom-up causality. Most importantly, emergent wholeness holds the possibility of genuine emergence of self-generating order from non-order. And for that, we don't need any quantum processes. This can happen within the classical world, within space and time. So it's on its own a type of unique wholeness that governs our world, certainly the human body, but certainly all the climate, weather, cosmic organizations. You see this phenomena everywhere. Quantum wholeness based on nonlocality, on the other hand, as we said before, also allows for the interconnectedness of everything, but it somehow exists outside and beyond space and time. This refers to the instantaneity of these connections, that there's no time delay, that there's an instant connection of everything. Now, the big question is, how are these two related? And how these two are related remains largely unknown today. And so the big question for science, and I think this is in our science program as well, that's guiding our work at the Fetzer-Franklin Fund, is to ask, how do these two types of wholeness interconnect? Emergent wholeness on the one hand and quantum wholeness on the other hand. So we're looking for a future scientific theory of meta-wholeness, which needs to unify emergence and quantum theory. And I think in what David Bohm talked about was jumping back and forth between these different types of wholenesses. And somehow he had this intuition that they belong together, obviously. Right now, science at least can identify that there are these two types of wholenesses. And how to connect the two, that is for future science. And certainly, you can understand better now the naming of our symposium series on David Bohm, which we called Emergent Quantum Mechanics, because the purpose of this work is to actually find the deep connections between the two. I will conclude just with an outlook on this, towards a relational science that I mentioned in the beginning. in all our goal areas, and I think in science, in whether it's physics, consciousness, or biology, you need to look at both of these levels. At the smallest level, at the quantum, you need to look at quantum consciousness. We need to look at quantum biology. We need to look at quantum physics, but also we need to look at quantum foundations. But I hope I've convinced you, or at least opened for you the possibility, that we also need to look at the emergent order in physics, the emergent order of science, consciousness as an emergent order, and biology as an emergent order. And a relational science makes the following assumption. It says, if you want to resolve or address or make progress, at least, on the issue of consciousness, maybe it's not enough to look at consciousness. Maybe we need to look at all of science, the whole of science. We need to look at physics, we need to look at biology, we need to look at neuroscience, we need to look at psychology, we need to look at sociology, we need to look at all empirical methods and all the data of science. But we also need to look at science itself, what the nature of science is to make progress in a relational science. So here are the final 3 slides before we end and start the discussion. This is an image of the standard hierarchical approach to science today, which we term reductionism, materialism, and best by the word physicalism, because fundamentally philosophers of science and scientists believe that physics is the foundational science, and that consciousness can be reduced to biology or neuroscience or brain science, and in turn, biology, neuroscience, brain science eventually can be reduced via biochemistry and chemistry to physics. But what are the foundations upon which physics rests? You know, as we said before, what makes possible even science? Are these foundations fixed or open to future revision? And so we need to ask the question, what are the metaphysical assumptions underpinning modern science, which actually make this case that everything can be reduced ultimately to physics, even quantum physics, all these domains. And so we are very interested in alternative metaphysics, alternative ontologies, alternative epistemologies in this work. And of course, David Bohm's vision represents a vast new holistic metaphysics. It does work on the epistemological side, and it does work on the side of ontology as well. And he also did work on what I didn't address here in the area of phenomenology itself also. But this is the standard model of science as a whole. It has been remarkably successful, as you know. Let's face it, we discovered the quantum through a reductionist method. But now that we've gone all the way into reductionism, materialism, physicalism, how can we flip this around? And this is where David Bohm wanted to go. He's saying that science itself, as I said before, is demanding a new non-fragmentary worldview, a non-reductionist, a non-physicalist, or a non-materialist worldview. And because he was convinced that the notion that all these fragments are separately existent is evidently an illusion. And this illusion, he says, cannot do other than lead to endless conflict and confusion. So he was deeply concerned that the fragmentary worldview that would come from the standard model has deep moral implications, and in the end would be limiting to humanity, and in the end destructive. And therefore, I will end on this idea, and that's why also John Fetzer, the founder of the Fetzer Institute, and with this the Fetzer Franken Fund, and has given the money to this, he was interested in a future relational science, which could overcome the materialism, the reductionism, and the physicalism that is dominating current science. And so maybe we need to look at these in relation without reducing these phenomena to each other. Maybe we need to allow for consciousness and phenomenology and agency to be dealt with on its own, and biology and physics. And as we hold these areas open without reducing to each other, maybe we can move from a reductionism of today to a new relational understanding of the facts of science. I'm sure David Bohm would want to do that. And that's why I leave, this is my final slide. And, you know, just one example. You know, here we, in the reductionist model, the standard model, you put consciousness here and you pass through biology and through physics to foundations. But maybe when we want to address the consciousness, we need to connect it to foundational thinking. We need to actually see where do our metaphysical assumptions come from that we use to study physics? And suddenly there's a connection to consciousness. So maybe we need to look at this in a way that interrelates these domains, rather collapses these domains down to physics. So I'll end with that question, and that's also the outlook of our own research program. And I think that's something David Bohm would have been really interested in. Would he be alive in the 21st century? The question, could a deeply relational science be developed, which, while maintaining a self-consistent view of nature, could include the dimensions of matter, life, and consciousness without reducing one to the other? And I think that would be the goal. And we clearly are not there, but we're working on this. So thank you very much. This ends my talk, and I'm open for questions.
Wow, thank you so much, Jan, for that. That was really amazing and interesting presentation. Yeah, if people want to ask questions, they can physically raise their hand or use the raise your hand function. I can see, Linda, you've had your hand up for a while. Is that right?
Actually, it's not me, it's my partner, Rocky.
I'm Linda's partner.
Okay, sorry.
Okay, so when we look at the Alice and Bob example, and we take the hypothetical experiment that Bohm set up in the fishbowl, where we have two cameras at right angles observing the fish observing Bob and Alice, one camera would see that there is instantaneous communication between Bob and Alice.
Well, I don't think you would say instantaneous. There would be an instantaneous information transfer.
Yes.
I don't think it would be absolutely right. He would say, because in a common rest frame, from one perspective, it actually is instantaneous. There is an instantaneous connection between Bob and Alice. You're absolutely right. What would be instantaneous is the information sharing between Bob and Alice, but not in a way that we can control this information flow for the purposes of communication. But yes, you're absolutely right. In this perspective, in a common rest frame, and that's what's meant by this angled camera, you do have this instantaneity, absolutely.
Thank you.
Thank you, Rocky, for that. I can see David Moody has a question or a contribution for you.
Yes, thank you. Can you hear me all right?
Yeah, I can hear you.
Okay, so my question has to do with implicate order, and it has to do particularly with the order aspect of implicate order. I notice when people try to describe the meaning of implicate order, they give the emphasis to the word implicate and contrast that with explicate, but they ordinarily leave out any attention to the word order. And that concept is kind of in the background and left undefined. And then when people use the phrase implicate order, it kind of has an implication of some form of subtle reality, such as, you know, things go into the implicate order and out of the implicate order, and it kind of gives rise to a feeling that there's some other kind of subtle space or reality where the implicate order exists. But I'm not sure that's the meaning of order. And I wonder if you could, because you used the word order quite a bit in your talk, I wonder if you could, and it's hard from looking at Bohm, because Bohm says order cannot be defined. So he's not terribly helpful with that term. I wonder if you could bring out the meaning of order, especially as it relates to implicate order.
Wonderful question, because in the example with the spiraling dynamics that I've shown you, right? I talked about this, let's call this the spiraling order.
Yes.
It's a form of order. And when you go below the surface, right, in emergence theory, it's not, when we use the term emergence, it's almost like, you know, you go from the implicate to the explicate. Something emerges, and even, you know, Basil Hiley in his talk talked about, you know, how the classical world emerges from the quantum world, as if the quantum world is hidden below the surface, and then what's become visible, it's emerging. And so the spiral, right, emerges in our classical world. But where did the spiral, what you're asking is, you know, where did the spiraling order exist? And I think the big problem, and I completely agree with you, is this assumption that there's some hidden order somewhere below the surface, like in a subtle domain, pre-existing, like a Platonic form, right? Yeah. Plato would say the spiral exists in another domain, and then it just pops into the explicate domain. Now, Aristotle who totally disagreed with him. He said, no, that was the big innovation of Aristotle after Plato, right? Who would have a very different conception of the relationship between form and content, and he called that potentiality and actuality. But Aristotle would not say that the potential exists in a subtle domain somewhere as an order, a potential order, which then becomes an actual order. The beauty in emergence theory is it actually does not have to assume that an order pre-exists at the random microscopic level. The order that happens when we see it is a function of the totality of the universe, of all the interactions, all at once, of everything interacting with itself. So it's the boundary condition. So David Bohm talked about, in the quantum physics context, of the boundary condition that is set up by a measurement process, right? That when you change an instrument setting, you change the boundary condition. And with that, you do a measurement. And it's by changing a boundary condition that a state goes from potential state to actual state. And it's not like a hidden order suddenly in that form appears, becomes visible. It actually gets generated in that moment from nothing. That's why I call it, this order is self-generated. It's self-organized. And that is so mind-bending, right? To me, it's as mind-bending as the concept of non-locality. That's why I said, right, we have two kind of wholenesses here.
Can order be defined?
Well, we do it, we do it in science, right? We have definitions of order. You can define order as information. You can define order mathematically, and on and on and on. But of course, the concept of order is in its sense indefinable, right? Because you can use the term order in any of the contexts. So it's a cross-contextual term. But the order itself, the question, where does it come from, right? And I love how you framed it, that you said, we shouldn't assume, and I don't think David Bohm said that, right? That the order is sort of hidden somewhere away, and then like magically it appears. It's far stranger than that.
Stranger, yeah. Good, thank you very much.
Well, thank you, David, for that provocation, and it's great to have you here. I can now
You have to say that again, James. We didn't understand.
Oh, sorry. Well, I was just thanking David, and it's great to have him here. And if I can see Mel has her hand raised.
Thank you. Thank you for the chance to ask something. I used to teach biology in special science high school designed to create scientists and engineers out of Filipino students. And I have this reflection that how we usually teach it in that school where Jonald and I also graduated from. It's very analytic in the sense that it can tend to be reductionist, and I realize that. And when I taught in a Waldorf school, we emphasized, in contrast, to very Goethean phenomenological sciences. And I realized that perhaps we have to reevaluate how we educate students in terms of the STEM subjects, because it seems that the science teachers have to be more comfortable with talking philosophy, and the philosophy teachers also have to be more comfortable with talking science. And I fear that if we don't do that, we keep producing thinkers who won't be able to solve these global problems that we have that are systemic and holistic in nature. And we keep on producing scientists who are very devoid of or are not cognizant of the philosophical origins of the science that they know, the current science that they know, which is very analytic and tend to be dogmatic in that sense. So I don't know if the group has any reflections, or Jan has any reflections on how we can transcend this lack of integrated aspect of education. Thank you.
If I may just briefly respond, completely agree with you. I was so, in my own life, I was so dissatisfied with the silos of knowledge. And that's why I really educated myself in biology, in physics, in quantum physics, in psychology. I have publications in 5 different fields that nobody would do that. Now, David Bohm was very similar in that, right? He thought the problems, if you want to solve the problems of the world, we have to cover all those different dimensions simultaneously. And unfortunately, there is no good incentive system to reward people who have who are seeking a holistic education of cross-cutting, connecting different fields. I had to fight all my life. When I went to Stanford, for example, I said, I'm only going to set up a lab. I hired a cell biologist, a computer modeler, a chemist, a medical person, an engineer. Each person of the 7 people in the lab was from a different field across campus. They've never seen anything like this. And after they spent 8 years with me, they all got professorships because they were integrated thinkers. They could solve problems in many different areas. But this was in the 90s. Now, it's slowly shifting. You know, at Stanford, for example, they set up a think tank on interdisciplinary thinking, at least. So it's happening, but it's happening very slowly. I think that the crisis that we experience on the planet, we really have no time. So the incentive systems must change. And we hope with our work, right, to do exactly that, to empower people to think cross boundaries. So I'm very glad that you bring this point up, because I think the educational aspect is key here. It's all for naught unless we can bring many people along in transforming the worldview.
Thank you. Thank you.
And thank you, Mel, for asking that and raising that point. I believe John Out has a question for you, Jan.
Hello, can you hear me? Can you hear me?
I can hear you, John Out, yeah.
Okay. My question or reflection is connected with David Moody's reflection of question earlier. I think David Bohm said in his, I don't know if it's Wholeness and the Implicate Order or The Undivided Universe, he said that the universe is not completely deterministic and it is not completely indeterministic. So what he's saying that the universe is in between absolute determinism and absolute indeterminism. Because if you explore the polarities, absolute determinism is that everything is determined. Basically, we are all robots and we are all billiard balls on the table. Now, if you say that the universe is absolutely indeterministic, then the universe is absolutely chaotic. If there's no order in the universe, everything is accidental, equally unacceptable. So there's, in between that, there is order. So I think what David Bohm is saying, because he denies the absolutes of those polarities, the order is in between absolute determinism and absolute indeterminism. And there you find this order that's neither deterministic nor indeterministic, but there is order nonetheless. You see, I mean, the universe will not have come out the way it is. Right? Okay, my second point, and also I like to confirm with you, John, the Schrodinger equation is where Bohm he transformed the Schrodinger equation using the Hamilton-Jacobi equation into deriving the Bohm potential, the quantum potential, right? And in the many-body problem, when he transformed the Schrodinger equation, it came out to be an equation where the quantum potential, well, all quantum potential forms have R over R, distance over distance. So that means that fundamentally, the universe has no distance in mind. It's fundamentally interconnected because the R over R aspect of the quantum potential underscores interconnectedness. And from that equation that Bohm potentially derived from the many-body problem, coming from the Schrodinger equation, it shows the fundamental interconnectedness of the universe, even though they are not, artificially created in the lab, right? Because in the lab you have this splitting thing wherein you can measure the two particles coming from a common interaction, but the way the quantum potential was derived for the many-body problem, when something moves here, the whole universe is moved as well, because of that fundamental quantum potential of the many-body problem derived from the Schrödinger. So embedded in the Schrödinger equation is a fundamental wholeness of the universe. So that's what's amazing. So I'm just going to ask, is that what Bohm was aiming at when he was showing the many-body problem derived from the Schrödinger equation, in deriving the Bohm potential of the Schrödinger, from the Schrödinger equation? Yes.
I don't know what intentions were, but I agree with you that if you take the quantum potential for the whole universe,
yes,
right, then
yes.
everything is interconnected exactly
Yes.
in the way that I talked about in the laboratory setup, right, with isolated pair members going off in different directions. But that would only hold, but the caveat here is, but this is very reminiscent, but also of Niels Bohr's take, right, on the universe, right? If you take the quantum wave function of the whole universe, right, you also have that very same holism. So to get that holism, you actually do not need the quantum potential in itself. You can also do it with the standard wave function as applied to the whole universe. In any way, whether in the Bohrian model or in the Bohmian model, you end up with this deep interconnectedness. Although Niels Bohr would say, it's just an operational mode that we're in, right? It doesn't tell us anything about reality, versus Bohm would say through the quantum potential, no, there is a quantum reality where this actually happens for real. And that's all I can say to that, Jonald, but good point.
Thank you. Thank you, John.
Thank you, Donald. I can see that Alan has a question for you.
Yes, Jan, brilliant talk. Thank you. Brilliant. My question is, in terms of this new science and taking science forward, I guess, well, the human physiology, the human nervous system is obviously many, many times more complex and sophisticated than any scientific instrument. And I'm really just wondering, what is going to be the role, what do you think the role might be of the human nervous system as an instrument to explore reality?
Well, there's two directions you can take that, right? You can either say, I want to model, right, the human nervous system and its capacity, like in neural networks, right, which are self-learning algorithms, where we try to, in the European Union, right, we have this brain project where, you know, the task is billions are spent on modeling the human brain, you know, cell by cell. And the end result is then to understand that we will learn a lot to produce technologies from it, like vast neural networks, self-learning networks, all the way to AI implementations of that. So that's one direction I can see. But I think your question was pointing into the other direction, right?
Yes, very much so. Yes, definitely.
But this way too. But the other way would be on the observer, right? If we believe that consciousness, observation, agency have to do with our brain and our nervous system, right? Which is an assumption we're making. I mean, some people might say no, you know, like the Greeks thought, you know, our consciousness is in the heart. That consciousness in the brain is a pretty late development, right? That idea. But if we believe the nervous system is the seat of consciousness, then of course to understand consciousness, we really have to understand the nervous system. And I believe also its quantum dimensions. So I do believe, right, that there is something to be found in quantum neurodynamics or something like this. But I don't know. We are far away from that at this point. You know, we are sponsoring a conference in Tucson on consciousness, you know, with Roger Penrose and Stuart Hameroff on quantum consciousness, looking at the quantum dimensions of the nervous system. But I've been there at the first conference in 1994, you know, now more than 25 years ago. And it seems like we're in a very similar state of knowledge today, even 25 years later. It's very hard to make progress on this frontier.
And could I just say, what about telepathy or scientists like Rupert Sheldrake, which would take a potential?
Also very interesting to us. I mean, if we, that's why we're interested in advanced methodology. We had a program in actually replicating some of the PK work, you know, that's going on, psychokinesis work, or anomalous, as we call it, anomalous cognition. If any of those experiments are reproducible, right? Or actually, which are claiming, you know, to use non-locality, for example, right? To connect different entities, or to connect the mind with a physical entity, or to connect two minds. That would be the breakthrough of the millennium. You know, I completely would agree with that. The problem is, I've been following the parapsychological literature, and I've met many of the researchers. I was at Paralab in Princeton with Bob John. I talked to Dean Radin at IONS. I even the person who found Uri Geller visited me here in Berlin. We had conversations. So I've been deeply interested in this whole field of science, of parapsychology. Unfortunately, after 30 years of engagement, I could not point to a single experiment that I believe today that it's actually solid. That's the problem. So I got disappointed, but highly interested, but disappointed. But I will not give up. Let's put it that way.
Thank you.
Thank you, Alan, for coming in. We've got Jean has her right, Jean Robertson.
Yes, thank you so much for this helpful and excellent presentation. That's just great. Your image of the two aspects of wholeness, there was an overlap. And I'm wondering whether there's a possible interface with a rapid oscillation between the two, such as you get in the concept of Spanda in Kashmiri Shaivism.
Can you, so you mean the image you're referring to is the image of on holism, where we have the global properties at the top and the local random dimension at the bottom, that image?
And they overlapped.
And they overlapped, right. And you're relating that to what example?
I'm wondering whether there could be a rapid oscillation between the two.
Yeah, I think that's, you have certainly states where, for example, in a nonlinear oscillator, or when you look at nonlinear resonators, that's exactly what happens. You have a resonance between the global level and the local levels, co-evolving as the state emerges, like a bistable state or a dynamical oscillating state. I think that's exactly what happens in these models. Yeah.
Thank you.
Thank you, Jean. I believe Andrew and Enrico have a question for you.
Hi, yes, two questions, and just really fantastic talk. First one about emergence, which you described as wholeness in space and time, and quantum non-locality as wholeness outside space and time. I'm always troubled about emergence and entropy. It seems to violate entropy, which is, as I understand it, a definition of time's arrow. The other question was a Jungian question. I'm a physicist turned Jungian analyst. If I understand you rightly, Jung's notion of the archetypes is wrong in a Bohmian view, in the sense that although archetypes per se aren't in the epistemological realm, they are nonetheless pre-existing ordering structures, if you like, or agents. Could you comment on both those questions?
Yeah, I'll try to. On the first one, you're absolutely right. The self-organizing states appear to violate our very notion of entropy, of the arrow of time in the universe, right? But what happens is, and this was really discovery of Hermann Haken and other people, is to explain that while information and the form is created locally, this comes at the cost of increasing the total entropy of the universe. So while you're reducing entropy by creating order where that form happens, you're at the same time generating more entropy throughout the universe. So the entropy balance is maintained. So you don't create neg entropy. You don't actually reduce the entropy of the universe. You only reduce entropy locally where that phenomena happens. And that's how that puzzle got resolved. Right? That was the important insight there. So overall, the entropy of the universe is not decreased by creating order. But what living entities do, what my body does, right? When you eat something, you take the order from your meal and generate more order in your body. And what you excrete is more entropy. And you have actually created more entropy in the universe, while locally your body has created more order. So it's a seeming paradox. How can you locally create order and not violate the entropy principle? So, but that explains that. On your second point, on the archetypes, I really don't, I mean, on Jungian archetypes, we actually had meetings in 2007, 2008 at the Eranos Institute in Switzerland on the original table where Jung was discussing those things. And I had the privilege of sitting there with the Jungian specialists of that have remained. And the idea of where, you know, when you say that here, let me make this connection. When you say that the spiraling form, right, this image I showed you is an archetypical form, just, you know, for the sake of the argument, where did that form exist before it appeared as a spiral, right, in our reality? The same question you could ask with the archetypes. Archetypes, are they really existing in a subtle domain and therefore have their influence on people? That is a metaphysical assumption that would, I think would not go along with emergence theory. And I don't know what David Bohm would think about that. I think David Bohm has discussed some Jungian concepts, but I'm not the expert on relating this to the Jungian archetypes, relating the implicate order to the Jungian archetypes. To me, it sounds like archetypes, the way I understand them, if I would not be a Jungian, I just look at what they're saying, it's really about identifying categories of existence, more of a psychological nature than of a subtle energy nature. But that's all I can say to that. It's not very helpful, but that's what it is.
Thank you for that. Just because we're reaching towards the end, can we take a question? One more question. I can see John has his hand raised.
Oh, hi. Fascinating talk. It made me, one thought I had was that the, you know, you talked about how the kind of the difference between science, the scientific side and the metaphysical side is effectively the observer. Or, to me, it seems like it's the observer, and you know, the question then becomes like, what is observing, which kind of goes into the with the hard problem of consciousness. And it made me also think of how I'm a Zen practitioner, and the founding monk of our school was named Dogen, and he talked about both the 10,000 eyes of the universe, basically that all the eyes, that basically like the universe is just constantly observing itself, and we are the observers of it as the universe itself. But also he had a chapter in his masterwork Shobogenzo called Uji, which translated to being time, which basically in my view, like, was talking about relativity in the 13th century, where he talked about how every monk walking up the mountain was his own being time, and he was effectively in his own frame of time. So I guess that's more of a comment than a real question, but I don't know if you have any thoughts on that.
You covered everything, right? The hard problem of consciousness to relativity. No, what I'm saying, I think the 10,000 eyes, right? If you take that quote, it really, you know, when it's the infinite, right? It really points to the infinite, that any act of observation involves infinity. I think this is, that's called infinite, the movie is called Infinite Potential, for good reason. And David Peat called his book Infinite Potential for good reason. And also when you look at Hegel, right? Hegel is all about saying that the self, the I, is an infinitely self-relating idea. It's an infinitely self-relating form. So what I consider a self to be is an infinitely self-relating form. And that sounds very Zen-like to me.
Mm-hmm. Thank you.
Thank you, John. Unfortunately, we are reaching the end of these sessions. Unfortunately, I can see people have their hand raised, but unfortunately, I need to close. Jan, would you like to just say something to close the session?
So really just thank you all for listening to me, but I also want to use this opportunity, since I see Paul Howard has joined us. I wanna really, I cannot how deeply grateful Fetzer is of the product he delivered, right? I mean, to me, we had high expectations on the movie. It far exceeded my expectations of what actually happened. And I congratulate you, Paul. I hope the journey continues, right? That we'll find great outlets for the movie, that this will reach millions of people in the future. Last time I checked, you know, on the cut that is available on the internet, we have the last 2 months, more than 400,000 people have viewed the movie, which is really nice. And I think this effort of Paul's, and I'm so glad we hooked up, right? When we organized the university, the London conference, you know, Paul contacted me, oh, can we shoot a little interviews with some of your people, right? That's how it started. And Paul convinced us, and we really connected. And I felt if anybody can do this movie, we couldn't do it justice, especially being a friend of David Peat and being at Pari together, being neighbors here. It was such an authentic relationship, right? And so Paul was able to draw on such an authentic resource of knowledge about David Bohm. And I think, I hope all of you think that the movie has done justice to that vision that also David Peat has always stood for and has put into the world. And so congratulations, Paul, on the movie. And I thank the Pari Center for the excellent work you're doing and putting up the summer school. This will have ripple effects throughout the universe in ways we can't, you know, fathom. And it's all for the good and the betterment of humanity, I'm sure. So thank you.
Jan, can I just say,
go ahead.
Can I just say thank you so much for your kind words about the film. If it wasn't for you, really, the film would not have got made. And can I just say, with my tongue firmly in my cheek, your talk today was almost as good as the movie.
Thank you. Thank you all.
Thank you.
Oh, thank you so much, Jan. It's been an honor really having you here. Thank you so much for your presentation, being part of our series. I can see in the comment section, there's been fantastic feedback about your presentation. So really, thank you very much. And thank you all for joining. Before we go, I do need to make the last final announcement. So first of all, this was the last official session of the series, but we aren't quite finished yet. Together with Beth Macy, we have organized a very special event. During this series, we've been looking at Bohm's work and ideas. Now, on Sunday, September 6th, we will be having a closing session entitled Moving Forward with David Bohm, made up of a panel of some of the presenters from the series. Confirmed panelists are Leora Liesberg, Lee Nicol, Shantina Saladini, Dave Strom, and Chris Dudney, with Beth Macy hosting the event. This session will be free to anyone who has participated in the series, and it's going to be fantastic, so I strongly recommend all of you to join. Given the success of this series, I can announce that we will be launching more events online. First of all, starting in October, we will have a 4-week series with Lee Nicol entitled Entering Bohm's Holoflux, Liberating the Explicate Order. We will also have an online dialogue running from late October into November, hosted by David Strom and Beth Macy. More information on these events and future will follow. If you want more information, I invite you all to subscribe to our monthly newsletter or follow us on Facebook, Twitter, YouTube. We post all of our news and events there. Also invite you all to support the Pari Center by becoming a friend of the Pari Center, our membership program. By becoming a member, you will receive a 10% discount on all of our events and receive our journal, The Pari Perspectives. I recommend to become a member, especially now as the Pari Center, the Pari Perspectives will publish 2 issues this winter, which to me are quite special. The first one, which will be published in September, is a special issue called the Pari Center 2020 to celebrate the 20 years of the Pari Center. This issue will include a collection of 20 essays from colleagues of David Peat, or people who have been coming to speak at the Pari Center, but also 20 essays by people who come back to the Pari Center and have been quite close to us. In December, we will publish another issue of the Pari Perspectives, which will revolve around the work and ideas of David Bohm, which will include essays by some of the speakers from this series. And so I recommend you all to be a member so you can get these special issues. As always, you can contact us by visiting our website, where we've got a contact us section, or you can just send us an email with from these email addresses. One is james@paricenter.com, which is mine, or eleanor@paricenter.com, which is Eleanor. Finally, before I go, I would just like to say thank you again to everyone, and from speakers to presenters to participants for being part of this series. The online summer series was born out of the COVID pandemic, where our conferences and courses live me, together with Eleanor and the Pari Center team, came up with this experimental idea, which at least to me has become a really great success. For this reason, I would like to thank you all for joining us, for coming back for each session, and for expanding and keeping alive the Pari Center community. We couldn't have done it without you, so give yourself a round of applause. And again, thank you all for joining us, and we'll see you again soon here at the Pari Center.
Thank you.
See you all September 6th. Looking forward. Yep. Beth, so happy that you will do it. Great.
Grazie.
Yes, thank you.
Thank you, James. Thank you all. And see you on the 6th of September. Thanks again.
Thank you, guys.
Yeah.
Bye.
Thank you all.
Bye. See you in September.
Thank you.
Amazing work. Thank you, Pari Center and everyone.
Thank you, everyone.
Wonderful session.
Thank
you.